So I want you to go, first of all, no quiz today. Just what I would have used, you addressed in your quiz last week. And your discussion question, simple and easy like usual. But I want you to go to today's assignment. And we're going to do some of these problems together. I'm going to do them for you. And then I'm going to have you in groups finishing the assignment. And so I'm going to show you how to do the mathy part. Now, what I've found in the past several years is the math here sometimes intimidates people more than the other sections we study this year. Like, even more than what's going to come later. And it's not that it's that difficult, it's just that we use quadratics. That's really the only difference. And so it's the only topic this year where we're going to use your traditional quadratic equations. And I know we've done those to death in your math classes, so I'm going to take some extra time with you guys to really model what this is going to look like, just to get you used to how does it work with things like this. So I want you just to scan through the questions.
My pen died. I'll be right back.
Super fast. Super fast. I want you to pick one for me to start with, and we don't have to go in order, but we can if you want. And I will say number 8, I don't mind doing number 8 for you, but I'm not going to make that the first one I do for you. So, read through and then just shout one out.
One.
One? All right.
Wait, whatever is not done in class is going to be our homework, right?
Mm-hmm.
Let's just do them all.
Well, I'm not going to do all of them for you, but my hope is that we do get most of them done before class ends. Where'd it go? Try that again. Actually, maybe it is...
Do we need to write the question?
Yeah. No. It's okay, just write number 1. Apologies for the moment it's taking to get this set up. I have a large canvas so I can fit a lot of questions on it. Okay. Sergio, would you, as soon as I finish resizing this just a little bit, would you pick somebody to read the problem?
Me.
Go for it.
A tiger leaps horizontally from a 12-meter high rock with a speed of 4.5 meters per second. How far from the base of the rock will she land?
Alright, so all we know is the height of the rock, which that's a pretty big rock. That's a small cliff right there. And we know how far or how fast she's going as she travels. So in other words, this is very similar to like the whole bullet shot from a gun horizontally. You know how fast the bullet's going? You know how high up you put the gun. The lab that I keep bringing up, this is all you would have for your initial information on the lab too. You know how tall the table was, and you calculate how fast the marble's traveling as it's about to leave the table. So, 5 habits say, what do I do first?
Write it out. Or
Draw a diagram.
draw a diagram.
Draw it out. So, here is my rock. Here is my tiger. And I start to draw out what I know. So, to start with, what do I know I know?
The height and the speed and the direction.
So a couple things. So the height, I'm going to put that over here. And remember, I'm going to talk about things in terms of your y initial and your y final, instead of just height like I did before. And then you said something about the initial speed. That's a very specific type of speed. Remember, we're talking about x and y directions right now. What initial speed do I know? Is it an x, is it a y, or is it at an angle?
It's an X.
How do you know that?
Because it's horizontal.
Right there. So that's the initial velocity in the x direction. You are going to have a lot of variables to keep up with here. Now, when I talk about the 12-meter high rock, do you feel like you want to put that, and it doesn't matter what you do, I will adjust the problem to whatever you want. Do you feel like you want that as the initial height or the final height?
Wouldn't it be the initial?
Honestly, we could do either one, because if we called it the final, it would be like, how far did it fall? But let's do initial, because that's what you said. And I think this would weigh, something to point out here, is this means that if this is 0 and this is 12, 12 is higher than 0, it means that you chose that direction to be your positive. And that's going to affect some things later in the problem. And while we're at it, let's go ahead and make the direction we're jumping our positive as well, that horizontal direction. Now I'm going to do something a little differently right now. I want the equations that I gave you last class. So Emily, I know you weren't here, but everybody else was here, so they should have them written in their notes. I want you to go through and find for me what were those equations, and once I know those equations, I'm going to put them, the rest of the variables, on my picture. And I will point out, because it's asking how far, I am okay if you only give me the equations that have distance that you're solving for. And Emily, as soon as I shout them out, you'll get these equations. Although you might have them if you did go through the videos like you should have over the break.
Want me to be honest?
I just kind of know what the whole high school thing
I
is.
definitely did not, but I will.
Okay. By the way, keep in mind, the opportunities for any late work are quickly diminishing, because that's kind of the trade-off with me disappearing, is I can't open up old things for you once I'm disappeared.
You know that I have an A in your class.
Yeah.
Because I've been turning everything in, and
And that's
I'm
awesome.
shocked.
You're doing good. You're doing good.
It's insane.
And we are going to have one more test before the quarter ends, and it will be while I am gone, guaranteed, because we'll actually only have one more lesson on this, and then I'm going to do 2D forces and do a test on both those things together. Still waiting on the equations, though.
Are you going to be... I would give them to you, but I don't know them.
Right.
Are you going to be here for that test?
No. It's going to be while I'm on maternity leave. I guarantee that much.
When do you think you'll leave?
Well, as soon as the baby comes.
Yeah, like when...
So the due date is... My due date is the last day that we have school before the break. So it just depends on if I make it that whole time or not, or if he comes early, I could leave any time now. So... Like...
You guys should give her the equations so I can write them down.
Yeah, we're still waiting. This just eats into the time that we would do other problems for you.
So I
I'm
have
about to go Google the video.
I have x of f
There we go.
Equals xi plus vix t plus 1/2 ax t squared.
Perfect. And what's the other one just for distance? So in other words, not a VF. Give you a hint. It starts like this.
YF equals YI plus VIY.
Is that a T?
Plus 1/2 AT squared.
AYT squared. So any of these that I put a little hook on the end, those are T's just because my plus signs, I used to write them more like the plus signs, but then I got confused. I was confusing myself.
Yeah, I just
whether they
couldn't
were
tell if
T's or
that one had a
pluses.
hook or not. Thank you.
Yeah, that one did kind of miss it. So, putting in these equations... Hi again. You're back. Putting in these equations is going to be helpful because then I can see what letters I'm missing on my picture. And I do need to put them on my picture before I plug them into the equation so that I make sure mostly that I get positives and negatives correct. So, what are some things that I'm missing on my picture? Zach E., go ahead and shout out one I'm missing.
Normal force?
No, look at the screen.
Yeah, like on the left.
Yeah, so it's got to be something that comes from these equations.
Oh.
So pick a letter that's not already on my picture.
The YF?
YF's right there.
Oh, XF?
I don't have my XF yet. I know that my tiger is going to fall, and the location where he falls is going to have some final position. And it's asking how far I'm going to fall, so in fact that's the thing, ultimately, that I'm trying to find. Alright, Gage, give me another something I don't know. A lot of letters here to look at.
Yeah. You do not know XI.
I do not know XI either, and I'd venture to say the edge of the rock would be my XI. That one you secretly do know. What would be...
Wouldn't it be 0?
It would be reasonable to call that 0 meters. Okay? Alright, so... Philip, give me another one. Any letter that's not on the picture yet.
Just a second. You don't know how long it'll take.
So, in other words, time?
Yeah.
Perfect. Okay. So I do not know my time. Tanner, give me another one.
AX.
And AX, I told you last week, AX is always a specific number. Look in those notes, tell me, what is AX going to be in every problem you do in my class? What was it?
9.8.
It was not 9.8. AX.
Oh.
Because we're going to ignore air resistance. But that is the number one mistake people will make, is putting in 9.8 on AX. 9.8 does not affect your horizontal at all. Should be right there with the equations that I gave you. Because we went through and defined all the variables in them, and then I went back and told you what some of them are. And AX conveniently is always a very specific number. Do you have the places where all these are defined in your notes?
Yeah, I have it. I can't find AX. It's the only thing I don't have, I think.
Okay.
I have AX in the meaning, but I don't have what the number is, or the figure.
Okay. I'll go ahead and give this one to you. Add it to the notes from last time, as well as this time. Because there's no air resistance, this one's always 0. Kind of makes things super convenient for us.
So AX will always equal 0 in all these equations?
Always. Every single stinking time. So, and it's because what we learned with forces, F equals ma. If we have no force pushing us in the X direction, and if we don't have air resistance, there's no force in the X direction. Gravity's the only force acting on us, even though we're moving to the right. The only force is pulling us down. The only force once we're in the air. Because there's no force, there can be no acceleration. Alright, now, while we're at it, though, Gabe, let's go back. 9.8, what did that reference? Because you were close, it just wasn't for the X direction.
Air resistance.
No.
Oh. Force of gravity.
It's your acceleration due to gravity, which is a vertical. Now, this one we are going to need to adjust. Do you remember here, way back, right here, when we said that our up direction was positive? What direction does gravity accelerate us? Up or down? Tanner's telling me with his finger. And if it's accelerating us down, how should I adjust my 9.8 to compensate for that?
It should be negative.
It needs to be a negative number. Alright. At this point, let's see if we've got everything. I feel like there's at least one thing we're missing. But, if I check on my picture, I've labeled my XF. I don't know what it is, but I've labeled it. I have my XI, and in fact it's 0, so I like to just cross it out to get ready for that. I have my VIX. I don't know my time, but it's at least on the picture. My acceleration in the X direction is 0, which conveniently means 0 times stuff is still just 0, so that whole thing goes away. I'm going to go ahead and cross it out too. My YF conveniently was 0. My YI I know. VI, I don't see that on the picture. What would be my initial velocity in the Y direction if I'm moving horizontally when I jump off the cliff? What would be your vertical velocity if you're jumping completely horizontally?
It would be 0.
It also would have to be 0. So conveniently that goes away too. And then I know my acceleration in the Y direction, and again I do not know my time. So I've got my habit 1 now. And then here, kind of my habit 2, 3, and 4, because I did pick my equations to help me get through, because I am going to use the same equations throughout. Now I'm ready to plug in my numbers and start solving. So we might not have done the habits quite in the same order that we went with, but I'm going to tell you for the equations I'm going to give you, there were 4 equations I gave you, so Emily, we do have 2 more to teach you. About if we want to know how fast we were traveling when we hit the ground, that's where the other equations will come into play. But for now, I want to play with these. Now we're ready to plug in our numbers. And if I don't know the number, I'm going to leave the letter in. And from this point on, it's not so bad. But these problems, because there are so many more variables, the picture does take more time. And again, this is more variables and more quadraticness than you're going to see even after this in this year. This is really the only section that will have this much setup. Which means I'm personally glad I am still here for it, with you for it. Alright, now there's a magical rule in math that says for one equation, you can have at most one unknown. If you have two unknowns, you have to have two equations. How many unknowns total do I have between these two equations?
2.
2. So I'm in luck because I've got two equations, two unknowns. I want to look for the one that's easiest to solve, even if it's not the thing I want to solve for. Which equation will be easier to solve for its unknown?
Bottom one for sure.
For sure. Go ahead and solve for it. I'll give you a head start.
Wait, I thought we didn't know what t was. I thought that was just a variable. That's not. I didn't know that. Is that part of the?
It is a variable, but if you have a certain height to your rock, it will take you a very specific amount of time for you to fall off that rock. Again, whether you're just falling or jumping off of it, if you're jumping horizontally. So we're solving for how much time it takes you to hit the ground once you leave the rock.
So is t a unit that's attached to a number, or
Yes.
is it just a variable?
It will.
Okay.
These are going to give us very specific numbers for this that apply to this situation. That's a
Okay.
very good question. And once you have it, go ahead and tell me what that is going to equal.
I got there and then I didn't know how to put that in my calculator, so I gave up.
I bet you could put that in a calculator.
Well, I have my calculator on my phone. I usually have Desmos pulled up, but
Desmos, by the way, Desmos does have an app that you can download to your phone. I use it.
oh,
Almost
that
daily.
is so nice.
Yeah, so just as a heads up, you can put Desmos on your phone. And if you have a computer with you, pull up Desmos or Google or whatever on that.
I'm gonna download Desmos right now.
Go for it. Like I said, it's super, super handy. Where I'm still tracking the COVID cases, I switch back and forth between doing it from my phone and doing it from my computer every day. But yeah, as soon as somebody has an answer, shout it out. And believe me, I don't believe it until I hear it from at least 3 people.
$1.5649215928
1.6, we'll say.
I got the same thing.
Alright, that's
So
2.
did I.
I think that was 3. Who said the last one? Sergio? Okay. Alright, once you have that, that's going to be the same amount of time for it to travel horizontally, right? Right? Okay, Kate and Zach S say yes. So, all I need to do now is take that time, plug it into the other equation, and I know how far it travels.
Okay, so now you're plugging in a number for T.
I'm plugging in the number that I found here. And I'm
Okay.
plugging it in because the whole idea of the bullet drop versus bullet fired, the thing about that was it takes the same amount of time no matter which one I'm dealing with, the same time to fall. And so I'm using that concept to help me with my math.
Okay.
That's what that video was all about, was to prepare for this moment. And I was very specific with the problems I picked for you, by the way. I only picked problems where something was moving horizontally. Next class, my plan is we're going to do the same thing, but what happens if I have like a cannon that I'm shooting at an angle? That's going to make the problem a little more complicated because there's a little bit of trig involved. Anyway, what's my final X?
7.2.
Okay, that's one.
I got 7.2 as well.
That's two.
I got 7.2.
I also got that.
That's four. Alright, and what should be the unit for a position? If I'm asking how far away did they land?
Meters.
Just meters, yep. Not meters per second, not meters per second squared. Certainly not seconds. So, there we go. Now these problems especially, those 5 habits that I taught you, they were for, like, I know that I've said many times, I taught them to you for all the problems, but I taught them to you for these problems more than any others. Because these problems, you saw how long it took us just to set up the problem. There's so many places to be so easy to make a mistake that if you're not following your 5 habits, really easy to go astray. In fact, let's go through and very, very quickly, I'm going to share with you the places you're most likely to make a mistake. So, there are actually, more than anything, there are 2 places you're most likely to make a mistake, and I would say that they both have to do with acceleration. So, most common mistakes. The first most common mistake actually did come up, which I appreciate, is saying that the acceleration in the x direction is 9.8 meters per second. That is not going to be true because you got to remember the acceleration is of gravity. Gravity only affects the y direction. What's true is it's your acceleration in the y direction equals plus or minus 9.8. The second most common would be to have a situation where you're going to say this number up here is some positive number, this number down here is some zero number. In other words, up is your positive direction, but you use acceleration in the y direction equals positive 9.8. We are going to have to remember when our directions fight each other, you have to account for that in negatives. We've had to do that before, but in this sort of problem, it's really easy with everything else going on. It's really easy to forget that. So your acceleration in the y direction in this case would have to be a negative 9.8 meters per second squared. Just those 2 things alone are going to be the most common mistakes for a problem like this. So let's do at least one more, and I'm even willing to do 2 more, depending on how long it takes you to respond when I ask you questions. And then let's have you practice these with your group. And again, whatever we don't finish in class will be homework. But I'll wait till people are finished copying it down before I go back to the problems. If you are finished copying it down, go to assignment, what are we on, week 15, I think? 15.1 and start looking through to decide a question that you want me to do. Okay, is anybody still writing? Alright. Alright. Pick a new problem for me and I'll do it for you.
Number 2.
Okay. Really, when it comes down to it, these are pretty similar.
Wait, do we need to submit what we do in class with the homework?
Yes.
Okay.
Yes, I do want you to include pictures of this with your homework. Especially since between the different classes, because you're one of my 3 classes, I grade all your homework together, but I'm going to be doing different problems for each class. See if this will behave for me this time. Alright, Gabe, would you pick somebody to read the problem?
Cade.
A diver running 1.6 meters per second dives up horizontally from the edge of a vertical cliff and reaches the water 3 seconds later. How high was the cliff and how far from its base did the diver hit the water?
Alright, so again, all of our pictures, really in general, look the exact same right here. Starts out that like that at least. The diagram with the numbers look different. And Cade, what's something I know from the problem?
How long it took, the seconds, the
Uh-huh.
time.
So the time is something that doesn't have to go right on the picture, but I like to put it still with my picture. Sergio, what's something else I know?
The diver's running 1.6 meters per second.
Alright, and I need to be able to label that. So, what does that 1.6 meters per second go with?
Hold on. The initial velocity. Wait, the initial horizontal velocity?
Perfect. Alright, now, conveniently again, this is a how far equation. If it asks for how fast, that's where I need to pull up those other 2 that I taught you last week. But because it's a how far, I think it's a good idea to go ahead and have your how far equations, which conveniently, you're going to use the same equations every time. You don't have to, like, that's the one thing about this versus the 1D motion I taught you. You don't have as many equations necessarily to pick from. You're just going to keep using the same ones over and over again. And using that, let's go through and finish labeling what goes on my picture. So Zach asks, what's something that's not on my picture yet?
YI.
My YI. So my Y initial, because I start up here, my YI has to be up here. Now, here's a question for you, Zach, and I don't care what your answer is. With YI, we're also going to have YF, right? So my YF, I know he's going to jump. He's going to land somewhere down here. It's not I, though. YF. One of those makes sense to be 0. The other one will be the thing I'm solving for. I don't care which one's 0. Which one do you want to be 0?
The initial.
Okay. We're doing this differently than from last time. So notice that your zero's up here, and this number, whatever it is, I'm going to assume it'll be positive. That means that I'm going from 0 to a positive number when I go this way, and I'm turning math on its head a little bit. It will have some implications in the problem, but very easy to solve, or very easy to account for. And while we're at it, let's go ahead and say that that direction will be positive. Alright, and just so I can keep track, I knew this, I know my time. I just said this would be 0, and I don't know this. Just so that way we can see what we've already accounted for on the picture. Alright, Zachy, what's another thing that's not on my problem yet?
XF again.
My XF again. Oh, and I actually, I had labeled the wrong thing when we were talking about how high, because there was how high and how far. So I am going to need this XF. And it turns out those are both things that I'm looking for. Now, along with XF, we have XI. And very conveniently, what does it make sense to call XI? What number? If you're at the starting block and you're running a race, how far have you gone when you're at the starting block?
0.
0. Pretty much always, your XI will be 0. That one I'm not going to say always, though, because maybe you started running before you got to this. Like, there's different reasons. Your XI isn't always going to be 0, but for our purposes, it's pretty much always going to be 0. Okay, so I now know this one, and it was 0, it went away. Gage, what's another one that I don't have on my picture yet? Looks like we got 3 more things.
You don't want the acceleration, the A of X.
And what's A of X always?
0.
And while we're at it, what's A of Y?
0.
No, it's not 0.
Oh,
It's a very specific number, though.
9.8.
9.8.
9.8.
9.8. There we go to both of you. Now with this one. AY is your gravity, remember? Your acceleration due to gravity. Gravity's always pulling you which direction? Down. Here, what is down? Down is up, says Tanner. Yeah, that's what you said. Down is positive. There we go, says Tanner. Alright, so that means in this case, I told you that 9.8 could be a positive or a negative. This is a case where it's going to be negative. It depends 100% on how you choose to write your heights, your initial and your final height, as to whether you're going to use the positive or the negative of the acceleration due to gravity. And mathematically it will not matter, just so long as you're consistent. Okay? We turned math on its head. We said that down was positive. We don't usually do that in math, but totally okay in physics, so long as I compensate by making that 9.8 positive. Which also, by the way, if we had to do our velocities, like a final velocity, I'd want to account for that positive to match that as well. Alright, we now have this. It was 0, so that all goes away. We have this. There is exactly one thing we do not have on our picture yet. Philip, what's the one thing we don't have yet? The one thing on my equation without a check mark or a question mark above it. Not counting the 1/2. I heard your mom more than I heard you.
Sorry about that. Velocity on the y-axis. Or is that what that says? I can't really see it
The
too well.
initial velocity in the y direction. And if we are jumping out horizontally, what is the initial velocity in the y direction?
I'm sorry, what was that?
If we're jumping horizontally, what is the initial velocity in the y direction?
I don't remember this one actually.
If we're jumping horizontally, look at your screen. If we're jumping horizontally, how big is the vertical part of that? How big is the y part of that? How much am I rising or falling before I actually start falling if my line is like this?
I'm sorry, I've got a lot of distractions in here.
Yeah, it sounds like it. You do. If you do, then find a new place to be for class, okay? Because like this.
Yeah,
That's a big deal. Somebody help him out. Phone a friend.
It'd be 0.
It'd be 0. Because if you're horizontal, there's nothing left for the vertical. Alright, which conveniently makes that all go away. Now's the easier part, where we just need to put it all together. The picture is going to be the hardest part to put together, but the picture is essential to make sure you have the right stuff in the right places. And I'll leave you to it and to tell me the answer. Once you have it, let me know.
Ness.
Ness?
Emily just texted me. She said her internet died and she will try to get back on.
Okay, I'm glad she let you know. Thank you for letting me know. I saw she disappeared, and so I was just prepping to let her back in. It's part of the online situation. But yeah, hopefully that gets figured out fast. And I am recording this, so... which, for if you get kicked off, is helpful. I don't always upload the videos, but if I don't and you need it, just let me know. And I definitely am uploading this one because of how much work it takes. Which, for all of you who are still here, if you want to review how to solve the problem, go through the recording again. It's one advantage we do have on this type of learning that we would not have in the classroom. Anyway, yeah, put these in the calculator, tell me what you get. I don't believe any answer till I hear it 3 times.
The top one is 4.8.
Okay, that's once.
Yeah, I agree with that.
I got the same thing.
That's 3 times, I'll believe it. What unit should be on it?
M.
Yep. Alright, and YF, tell me what we get there.
I got 44.1.
That's
I got the
once.
same thing.
That's 3 times. Alright, one unit should be on that. Height. What's the unit for height? Which is still a distance.
Meters or M?
Just M. Meters. Alright, and there you go. And that ding means let's send you to your breakout rooms. So here's the thing. Give you a minute to finish copying down what you need to copy down. Or a moment, I should say, a full minute. Alright, Gabe, are you writing stuff? I can only see your forehead.
Yeah,
Okay.
yeah, I'm done.
Okay. And Gage, you got it? Tanner's got it. Zach, I don't know if you got that copied. I know you're texting Emily for me, I think. Or at least that's who I assume you're texting. Okay. Alright, now, here's the thing. We did 1 and 2. I want you to do 3 through 7. They're all going to be very, very similar. Now, this is the one where I wish Emily was here. This number 5 is the only one that is asking about a speed, although that's the initial speed, so you're good there. You actually don't have any final speed. So you can keep using the same 2 equations the entire time. Just to make sure there's nothing that references a final.
Are we gonna have to do 8 on our own? Because that one looks kind of hard.
8 is the more difficult one when it comes to the picture. What I'm going to do is while you are in your breakout rooms, I'm going to go ahead and make a video for 8 that you can go back and watch. You still need to turn it in, so that's going to be my proof that you went through it on your own. And you need to show me all the steps. Don't be giving me just an answer at the end. That's not what I want. But I'm going to send you into your rooms, and I want you to do these 5 problems. Again, the setup is going to be the hardest part. You're going to really need to be careful about that. And when you turn it in, I do want to see all 8 problems on there. Okay, so I know with Emily losing internet, that was just Emily and Zach in the room. Zach, I'm going to put you with Tanner and Sergio. And then when Emily pops back in, I'll put her in there too. Okay. So let's get those breakout rooms started. I am going to hold you for at least until 10:20 today. I will always try to get you out a little bit early, but this is just one of those classes where it's not going to be practical to expect a 45-minute lesson out of this. Alright, rooms are now open. If you get stuck, let me know. But I'm going to make this video while you're in your rooms, so I might not come right away.